In this video, we're going to be looking at quadratic sequences. Now, in a quadratic sequence, the second difference is always constant, which means the number is always the same. So if we look at the first pattern here, so I'm going to find the second difference between these terms. To start off, we need to get the first difference. So we have 6, 10, 14, and then 18. Then the second difference, so we have 4, 4, and then 4 again. So since the second difference there is the same number, that shows it's a quadratic sequence. Okay, let's do the same in the next sequence. So we have 3, we have 5, 7, and 9. So then getting the second difference here, so 2, 2, and 2. So because the second difference is constant, that shows it's a quadratic sequence. Now, we need to be able to find a general term for a quadratic sequence. Now, in the Leaving Cert ordinary paper, they will always give you the formula in a question. And if we follow the steps here in the yellow box, these questions are not too difficult. So, first step is we need to sub 1 into the formula for n and equal it to the first value to form an equation. So, I'm putting 1 in for n, so t1 equals, so I'm putting 1 instead of n. So every place I see an n here, replace with 1. So 1 squared plus b times 1 plus c equals then the first term. So our first term is 7, so equal it to 7. So then we have 1 squared is 1, b times 1 will just be b plus c equals 7. So then b plus c is equal to 6. Because when you bring the 1 to the other side, it'll be minus 1. So that's our first equation. Now, step 2 is we sub 2 into the formula for n. So instead of 1 now, I'm putting in 2. So replacing n now with 2, so we'll have 2 squared plus b times 2 plus c equals the second term now, which is 14. So 2 squared is 4. b times 2 is 2b plus c equals 14. Bring the 4 across now, so it'll be 14 minus 4, which is 10. So then 2b plus c is equal to 10. So now there are two equations. So now I need to solve a simultaneous equation with these two equations to find out what b and c are. So b plus c equals 6 and 2b plus c equals 10. Now I'm going to multiply the top row by minus 1. The minus c and the plus c will cancel. So then b is equal to minus 6 plus 10 will be 4. I'm going to sub that now into one of the originals. So the top one's a lot easier. So that will be 4 plus c equals 6. So then c equals 2. Okay, so put those now into the original formula of Tn equals n squared plus Bn plus c. So Tn equals n squared plus 4n plus 2. And there's our general term for that quadratic sequence. Okay, let's have a look at one more. So again, we're going to follow the same steps here. We're given a sequence and we need to find a general term for the quadratic sequence. So step 1, let's sub in 1 instead of n and equal it to the first term, which is 9. So replacing n, so we'll have 1 squared plus b times 1 plus c equals 9. So 1 squared is 1, b times 1 is 1, b times 1 is b, plus c equals 9. So then b plus c equals 8. Because bringing the 1 across, 9 minus 1 is 8. So that is our first equation. Now, next step, sub in 2 for n. So we'll have 2 squared plus b times 2 plus c equals the second term, which is 13. So now 2 squared is 4. b times 2, that's 2b plus c equals 13. Bring the 4 across now. that'll be minus 4. So 2b plus c equals 13 minus 4, and that'll be 9. So that now is our second equation. So just like the previous question, we now solve a simultaneous equation to find the values of b and c. So I'm just going to write them out again. So b plus c equals 8, 2b plus c equals 9. I'm going to multiply the top row by minus 1. Now add straight down. Minus c and the plus c cancel. Minus b plus 2b is just b. Minus 8 plus 9 is 1. Okay, so let's sub that now into an original. So I'm putting it into b plus c equals 8. So it'll be 1 plus c equals 8. So c equals 7. So my two answers are b is 1, c is 7. Okay, so I'm just going to put that now into the original formula. So Tn equals n squared plus bn plus c. So now Tn equals n squared plus 1n plus 7. Now we wouldn't write 1n just like we wouldn't write 1x. So I'm just going to write it as n squared plus n plus 7. And there's our answer.